down the front. There's plenty of space. Okay, good to go. Good afternoon, everybody. I hope you're all enjoying it so far. Is everyone enjoying it? Yes. Having fun? I've got a choice. I could do, just to prove I'm not a lazy English guy, I could do this in German if you wanted me to. Hands up who wants me to do it in German. There was two. Okay, I'll carry on in English, and I hope you'll understand me. Who am I? I'm Andy Gumbrecht. I now work at a company called Phoenix Contact. I used to work for Tommy Tribe. I'm sure you've seen the Tommy Tribe logos flying around here. I moved on from there. I'm happy to have moved on to a new challenge. Still using everything I learned from Tommy Tribe in my day-to-day. Why am I here and talking about testing? What have I got to do with testing? I promise this might be the only time I'll ping the book. We wrote this book, so Alex Soto, Jason Porter, two Red Hat guys, and myself wrote this book. I was originally asked could you just do like one chapter and review a couple of sides? And I went, yeah, that sounds like a project. And 3 years later, I did 5 chapters in this. It's an 11-chapter book, and it took a lot of work and a lot of research. And I just want to basically introduce you to some of the stuff that I was introduced. So I wouldn't claim to have been a testing expert. I was testing my code. Hand up who tests their code. And everybody's hand should go up here. I'm still seeing people. Everybody should be testing their code. We wanted to focus on something that was current. Obviously, microservices are current, so we wrote the book Testing Java Microservices. But you could apply this to different levels of testing. Let's just say there's a focus on microservice. And I think to answer this question, it's kind of an important question. I could stand up here and go, this is what I think a microservice is, and you would have no idea. I'd give you my idea of what a microservice is. And if anyone disagrees strongly, then I have some boxing gloves just down behind here, and we can come up and we can have a bit of a game on it. It's the tip of the iceberg. It's kind of funny because when I searched for an iceberg, this was the first clip art image that came up, and I thought, yeah, that's kind of like an iceberg. It's the tip of your ice lolly. No, really, it's the tip of the iceberg. It's this bit, this little bit at the top. I think there's a misconception, and again, this is opinionated, it's my opinion, and if you disagree with me, then feel free to disagree with me, but I think there's a misconception that microservice means it's got to be small, and it's got to be zappy and quicky and run on all containers. That's not necessarily true. That's up to you. I think that's up to you. There's no specification that says what a microservice is. So I just like to think it is the surface area that's exposed, and the iceberg is probably the best way of doing that. So it's as big or as small as you want. If you have an Oracle database underneath your microservice, it's not going to be small. It will be the size of an Oracle database and your service on the top. And that could be quite big. The idea is behind microservices, they're scalable. So you scale microservices. And you want to expose them to the outside world. So it's the surface area that you're exposing to the outside world. Some people say they have to be self-contained systems. I don't believe that's true either. Self-contained means everything goes in the top of the iceberg and everything comes out of the top of the iceberg. But I've had several cases, and a good example is the argument I used to win the the topic I used to win the argument was, I had a log stash that was chucking loads of stuff in, and I just needed to provide a microservice, but filtering out the stuff from log stash. So was I going to feed everything Logstash was collecting in the top of the iceberg and then deliver it out the top of the iceberg? No, obviously I'm going to be pulling in everything from Logstash underneath, and I'm just delivering it through that surface area. So that was it. That was the point of testing for me. I'll go the right way. It's your party, and I used to say the goal is just to test the beer, but in the interest of political correctness, I'm cut that out and said wine now, so everyone can drink wine. I kind of missed my thing at the start, which is nerves when you stand up here. So I'm just a developer. I'm not a guy that does this very, very often. Someone once told me, imagine the audience is naked, and that will help you calm your nerves. But in IT, I seriously think we need to get some more ladies into IT. So power to the ladies. If you want to come to the front and help me lose my nerves, that would be great. No. So it's your party. It's up to you. Where do microservices start, or where do they come from? Well, obviously, they can come from a blank sheet of paper, but originally microservices evolved from the monolith, and so we have our components inside the monolith. The issues with a monolith is when you want to scale a monolith, then you basically feed the monolith traffic, and it gets too much traffic, I'll scale everything. So you take everything and redeploy the whole thing. That would be a whole app server, all the applications running on it, so you'd scale the whole thing, and that's the way we used to scale stuff. And it kind of works. It would be a lie to say it doesn't work, because we've been doing it for 20 plus years, so obviously it works, but it's just not very efficient. So then along comes the microservice. So we still have our monolith, and we're still identifying the traffic. And what we want to do is actually identify where is our bottleneck. So analyze the application. Where is the break point in our application? What's breaking? What's creaking at the seams? And then we just extract that as a microservice. And then we can scale just the microservice. So we don't need to scale the whole application. We'll just scale our microservices. So you can still have your big creaking JBoss or WebSphere application servers, and you can cluster those, and they will work in that way, but you identify the bottleneck and you extract these microservices, and that's great. That's what we should be doing. And we still need to test those microservices. So whatever we're testing, we apply the test pyramid to. Does everyone know the test pyramid? Nope. Okay. Some of you do. He's going to stand up and tell you now all about the test pyramid. No. The test pyramid basically says we have a lot of unit testing. So down the bottom, all the unit testing, whatever you're developing, obviously your microservice is still going to be an application, and you're still going to unit test that application. You're not going to take anything away. You're going to add integration testers, sorry. And the difference, so one difference that you're going to have to add to a microservice is service virtualization. So you're still going to be taking your unit tests, so testing individual parts of your application. You put those together in an integration test. But then your microservice is kind of standalone, and it's on its own, and it needs to work with other services. And so we introduced this thing, service virtualization. We'll look at that in a minute. And then finally, you've got end-to-end tests. So we're still doing all the testing that we do in everyday application today, and we're applying that to microservices. And we're still going to be doing things like UI automation with our integrated services. The difference with an end-to-end test in the microservices scenarios, we have potentially a monolith and several microservices, and they all need to be up and running to do end-to-end testing. So end-to-end testing is having everything in place and testing it all together. So we're not changing that in any way. I'm going to run through this fairly quickly. I could probably do a whole hour's lesson or more, in fact, a whole day on REST testing. And we're going to be using, for our testing, REST assured. And what I'll do is I'll just pop into some code, show you a little bit of code, and then we'll go back to the next technology, and that's the way it will work. And this is where it all breaks, as you know. So. And unfortunately, I can't see that anymore. If I was facing this way, I wouldn't need my glasses. So this is basically a REST test. And everyone saw Venkat's talk this morning around simplicity. And that's the idea behind REST assured, is that we take RESTful endpoint testing and we make it nice and easy. So there's nothing magical about this. It's just an API that's been designed to fully understand how to test RESTful endpoints. Why are we testing RESTful endpoints? Probably because 99.9% of people are using REST as their microservice protocol. It's not necessarily true that you need to do that. It just seems to be that's what everyone's chosen to do, and we should all be doing it. There are other methods for testing other endpoint technologies out there. So this is Java testing Java RESTful endpoints. And this is a Spring Boot application, and all we do is we'll just fire it up, and we'll just watch it do its thing. And there's no real magic behind it, apart from it gets a response from a Spring Boot application that fires up. It reads from the actuator health test that everything's working and displays that information very, very simply. And that test is reasonably quick. And if we scroll all the way down, we'll see our output. If I go here. So we just basically received some content. Scrolling, where are we? All right, I'm not scrolling. Okay, I can't scroll that. You see the system print out, basically the test is passed, it prints out the response, and it tests this response, and you can see that the assert is fluid language just for testing your RESTful endpoints. And that's rest assured, so if you're doing any kind of RESTful testing, that's a good tool to use. But then what happens when your service is not the service you want to test? You want to test a different service, or you want to test two services together. This is where we start to introduce something that's called service virtualization. This is little more than capturing the response of the service that you're testing with. My pick for this is Hoverfly. There are, again, various frameworks out there. I think WireMock and Hoverfly are the most well-known. I would say WireMock is more comprehensive, so if you're doing really, really extensive testing, then probably go for WireMock. If you're just doing REST testing, then Hoverfly is more than capable and would be my choice. And that tends to be what people are using these days. What it does is it captures a response, or you can define the response that you want your service to capture. And so it can simulate a service call. And again, the best way to do this is to show you a little bit of code, and this goes a little bit further than the last test. Zoom it in. And I used to do this in Darkiller. I think Darkiller, most developers are using Darkiller, but I read an article fairly recently that it's actually really bad. You know when they used to say, don't eat eggs because eggs are really bad for you, and now they say, well, actually, eggs are pretty good for you because you can eat eggs. My favorite one was like a couple of days ago, literally 2 or 3 days ago, where they said, you can have up to 25 cups of coffee a day, and that's fine. So I tweeted that, brilliant, developer blood can now be drunk by everybody. Because that would be half my consumption of coffee a day. So we can all drink coffee again. And it's this test is basically then taking your service, and it's canning that response. And I'll run this test and show it to you. But here, we're going to record this. This is in capture and simulate mode. So what this looks for is a file called scenario.json. If that exists, it will replay that. But it currently doesn't exist, so what I do is I'll run the test and we'll create it. And again, this is just another Spring test, exactly the same as the last test. It's using the same RESTful assertion. And we run through, and the test passes. And you can see my IntelliJ is now prompting me. Something's changed. Something happened there. What happened is, in my Hoverfly directory over here, I have this magic file created, which is the scenario.json. And you can see it's just a JSON file, but it's actually captured the full request and response from my service. So what's important about this? Well, imagine that service is not a local Spring Boot application. Imagine it's a real-world scenario like I have in my current development, Contentful. So Contentful is a headless CMS system, and we're writing a rendering application that reads from that Contentful service and delivers HTML. Very simple. But Contentful charge me money. Every time I call that service, they charge me money. If I'm running a team of 10 devs, and those 10 devs are running their tests every time, and when they deploy to their CI/CD environment, those tests are running against Contentful. I'm actually paying for testing. So I've recorded this, and just to demonstrate on the Hoverfly side, I'll actually disable the Spring boot up. So now I'm not actually going to fire up a service. This is now just a test, a unit test per se. And we'll run this test, and now The hoverfly rule is basically reading this scenario JSON file. So it wasn't there before, so when it's not there, it says, okay, I'll speak to the real service, I'll capture that. Now I have a scenario JSON, I'll replay that canned response. So you can see this test is now not firing up a service. It's substantially faster because I don't have to fire up that service. But here what it is actually doing is simulating talking to that contentful API endpoint that costs me money. Now it's not costing me a single penny because I'm reading it from a file. And if I just remove this file and run that test, as you would expect, it would fail. And there it is, so no response available. If I want to recapture that, obviously, just re-enable the service that I want to talk to. And we'll run it again. And you'll see in the hoverfly directory, edo file will get added. He says, I'm not going to analyze that. Oh, I know, because obviously I still had it in capture mode, and I deleted the file, run the test, it failed, but what it did is it recorded the empty communication, which obviously I don't need now. So I'll get rid of that. Run it again, and it will work this time. So it's a bit of a manual thing. So how does that work in the real world? If I'm talking to the Contentful API, well, they version stuff. So as long as I'm talking to version 1 of that API, I can record version 1 of all my communication with that API, and nothing changes. So they guarantee stability. So you should be guaranteeing stability in your APIs that you deliver. But if your APIs are actually changing and you need to re-record that canned response, the simple way to do that is in your pipeline, delete those files. So just delete those files and then check the latest version back in. So I have that as part of my CI to delete those files once a week. And they talk to Contentful, and so I only pay for all my test suite to run against the Contentful API once a week. And that way I know all my stuff is up to date and working, and they've changed nothing in the API. But usually you would version your API. A step past that, and I'm not going to do any code on that because it is really complicated, and I won't lie to you about it being complicated, is contract testing. Now, contract testing is exactly the same as what we've just seen, so we can that response, and I put those in my version control, I keep those in my local file system where my application is, and I check those into version control. And then when developers check out that project, obviously they have the canned response already, and they don't even test, they never need to know that they're not talking to Contentful. But with contract testing, we start looking at multiple services from multiple teams, and it's easy to just delete that file manually if you're like 1 or 2 teams and you have a CI that deletes that file. But what happens if we have 50 services? Well, that becomes really impractical. You can't expect people to go and manually delete their files and stuff. And so this is where the packed server comes into play, and this is a standard now, so you can go and check it out. And again, this is just an introduction, so go and look it up on Google. You'll find lots of information. I thought it was really interesting, the explanation of pact, which is a formal agreement between individuals or parties. The country negotiated a trade pact with the UK, or not. Let's keep our fingers crossed. Yeah. It does exactly the same thing. So that canned response, that JSON file you just saw, all it does is it centralizes it. So I would produce from my service the canned response, and I would store that on the packed server, and anyone that wants to consume my service, they consume that canned response from the packed server. So if I have 50 services and 50 teams working on individual services, they would all push their scenario JSON to the packed server, and anyone that consumes it takes it. And anytime I change something in my application, the packed server actually detects those changes and lets consumers know something's changed in the API. And it will provide versioning. But it's a huge, huge topic. But if you're going to be developing lots of microservices, then certainly look at packed as your choice there. And then, of course, we have this huge end-to-end testing scenario. And this is the big change. So this is where we really need to start looking at how we're going to sew all this stuff together for our end-to-end testing, because they're still the most important. They're also the most difficult to write. They are the most time-consuming. They're really annoying that you can pull your hair out trying to write these tests. But that, for me, for some reason, equals fun. We're developers. We like that kind of thing. It's a challenge. So it poses a challenge, and it's a challenge we need to solve. So everyone in the room knows Docker, right? So Docker, everyone. Who knows Docker Compose? So about half. So all you people, so the 100% of you that know Docker, that's great. The 50% of you that know Docker Compose, that's great. The 50% that don't, you really need to start using it. It will genuinely help you in your testing. I'm just going to go back to the IDE for this. And I will find it. There it is. So I have a Docker Compose. So my service, Docker Compose, and I need to zoom in on that, I think. So my service actually needs a Kafka in place. So I could have a Kafka running and feed that information and clean it up every time. But that would be really kind of painful. So what we can do with Docker Compose is we can fire up containers as a batch. And this is just a really simple one. So when I need Kafka, I'm going to need Zookeeper. So Zookeeper is like the coordinator for topics, and Kafka is a service. And then there's my application that runs. So what we can do here is actually define all the containers, and you can see the syntax is as similar as you would be on the command line for Docker in this Docker Compose file. And then when we run that up, then it will start that service. So I'll just start that. And it's as simple as doing a Docker Compose up. And it looks for that Docker Compose file in the root directory. And we can basically see Zookeeper and Kafka firing up on the command line. You can suppress this. You can run this as a daemon if you want to, but that's just showing you it running up. And then to shut it down, anyone hazard a guess? Down. Down. If I just switch back there, then you can see that cleanly shuts down those services. So Docker Compose, really useful way of firing up multiple services. So those are the services that you could be canning the responses to, for example. So we could use Docker Compose or Docker and service virtualization. So I need to fire up those services. I can fire up team-wise new fandangled service that they've invented, but I don't want to fire up their service every time and test against it. So I'd fire it up. They would give me their latest image. I fire that up into a Docker container, and then I would record that response, and I don't need to do that anymore. But if I wanted to actually save some information on that service or use that service rather than just test against it, I actually want to change stuff and use that. That's when I need that service as part of my test. So I need to fire up that service, and this is Docker Compose for you. So it's just an orchestration for containers, a nice way of starting and stopping stuff. And then this is kind of my pick, and I said I wasn't going to mention the book again. There's quite a lot of this in the book, which is Arquillian. Arquillian is a Red Hat project or a Red Hat sponsored project. It's actually run by Alex Soto, so the co-author of this book. He's the lead on several of the modules for this thing. And Arquillian used to be, and I'll say that again, it used to be an EE testing framework. So it's very geared towards application servers. However, that's totally changed. So if you, well, I'll ask, who's heard of Arquillian? Quite a number of you, which is good. So for those of you already using Arquillian, you can use them for anything these days. It doesn't. So if you're doing Spring testing or anything like that, then you can still use Arquillian. It's no longer just a container testing system. It's a testing framework. And why would I use a testing framework? Because it just takes away a lot of that boilerplate code. this is kind of the magic rule, so it's a class rule. This is also relatively new in Arquillian, so we used to have lots of deployments defined within our test environments. We don't necessarily have to do that now, but because I'm using the test framework and not testing a container, I just define this rule, and what this rule does is basically allow me to test my application using some magic, and I'll show you some of the magic. And this is this Arquillian XML file. So Arquillian comes with a lot of standard configuration, but it's modular. So they provide things what they call extensions. And you can see here we have a Docker extension, we have a WebDriver extension, and we have a Cube drone extension. Don't worry about those names. There are just probably 40 different extensions from the framework, ranging from database through to SAP simulation, through to any kind of utility that you would need in your testing scenario that you can imagine. So if I'm testing against databases, I don't want to fire up a database. I want to have like a local database, and I want to seed that with information. So Arquillian provides this magic kind of framework, puts it in place to allow you to do all that in a very transparent way. And again, it's that class rule basically looks at this file and says, what do I need to do? And here's an example test. And we'll have a bit of a bonus round on this test, but basically this Arquillian class rule looks at my test class, so it loads up, it looks at my test class and says, what do I need? What does your test want? And something that's really interesting here is the WebDriver. So hands up who's doing Selenium testing, UI testing. More less than I was expecting. So Selenium is like the standard WebDriver for manipulating or let's say remote controlling browsers. And there are various drivers, so like the Gecko driver for Firefox, and the Chrome driver for Chrome browsers, and there's an Edge driver for Microsoft Edge. They all implement the Selenium WebDriver standard. And what that means is you can write some code to test against or remote control a browser, and it simulates the user journey through a browser. So your microservice might not have a UI. In fact, a lot of microservices do have some kind of UI, so they have usually some kind of configuration UI or minimal view of what the service is providing, or some kind of view for collecting the statistics from the service. And so there is, for even just a simple microservice, a fair chance that you'll have a UI, and you would want to test that UI. So your end-to-end test needs everything in place, including a pretend user to click the stuff in the browser, unless you want to actually fire up the browser, call up your UI, and have a list of A, yep, B, yep, C, yep, we'll do that. That would be extremely tedious if you do that manually. So people still do that, and I guess for the people that are not familiar with Selenium, I mean, hands up who's using UI automation for their UI. So basically, it's the Selenium guys. So this is a big topic for everyone in the room. Your web services are generally being consumed somewhere, and they might be part of a larger application. In an end-to-end test scenario, we want the whole UI. So we want everything. We don't just want to test our endpoint. We want to have 5 services in place. We want to have the UI, and we want to have a simulated user clicking through the web page, entering details, calling your services. So the UI is what interacts with your services and provides the feedback. So this test, actually, because I've defined in my Arquillian the WebDriver, I'm going to be loading Chrome, but I can change this. So this is a property that I've set. It's an XML file. It's in my build, so I can swap that out for a property that comes from my command line. And so I can run the test against the Chrome browser, I can run the test, exactly the same test scenario against the Firefox browser, and I can run it against an Edge or any other Microsoft browser. And I'm using here Arquillian to sew all that together. So this is kind of the bonus. This is something I like to add to all my tests now. And I was very, very skeptical. Who recognizes this syntax? Brilliant. So, behavior-driven development, BDD. I think it's fair to stand up here, and the guys sat down there that have just put their hands up would agree with me. It's the future. I think everyone's going to be doing BDD testing. So if you've heard nothing about BDD testing, behavior-driven development, I'm sure you will in the near future, because this is the way we talk to our product owners. So as developers, we usually sit in our dark rooms and we have our test scenarios and we write our tests and we don't tell anyone. We just say, yeah, we're testing, and then you provide some code coverage statistics. That's bottom up. Come in. You're late. Okay. BDD is from our product owner. So this is top down. I wouldn't write this. I would expect my product owner to write this for me. And it's written in a natural language. This is just a stupid example, but anything you can imagine you can say in a natural language, you could write in this file. But I'll just read it. So feature, this is feature 1. Fairly obvious. Scenario, this is scenario 1. That kind of suggests you can have more than one scenarios. You can have an endless number of scenarios. And then we all know the given, when, then. So given my simple Spring Boot app is running, when the browser is available, then we can control the browser. And that's come from my product owner. That's his expectation. And now for me as a developer, it's like, well, okay, I can interpret that, and I'll write some code behind it. And this is kind of what I like about it is the integration in the IDE. So this has nothing particularly to do with testing microservices, but this has something to do with remote controlling your browser in a nice, easy way that you've obtained that information from your product owner. So when I click here, we can see that there's some code back behind that. Now, I know that this is Java, but there is also JavaScript frameworks that do exactly the same as this. So you don't have to do this in Java. This is my preference to work with the Arquillian framework in Java. I would say if you're running a Java application, if your service is Java, then I don't need a JavaScript framework to test my UI. I would use the Java framework to test my UI. But if I'm writing a JavaScript application, then I would use a JavaScript API to test my applications. And so this it also exists in JavaScript. And what I have here is just a browser navigation to a URL. So I'll just go ahead and run this. And this is where, fingers crossed, it's going to work. No. I have a pull. I even have this prepared. So I have a merge request in for this, which is this guy here. So that error message is erroneous. It's not a real error message. It's just printing something out that should be a warning. We'll continue through. I promise you that's what it is. So now what this is doing is firing up the test and running that BDD. And eventually we'll get green ticks. Now, the magic behind this was, in this Arquillian XML, I actually defined my Docker Compose. So the Docker Compose you saw earlier is now being used by Arquillian. And if we look at the log output here, scroll down, and we'll find the containers. So here's the containers firing up in the background. And so what we've done is to use this compose file to fire up the services that I need for my test. And then my test ran, and you saw the browser being remote controlled to run that test. Or did you? The only browser I have running is here, and there was no test running there. Nobody saw anything running there. Did anyone see anything running there? No. So this is kind of like the real magic behind this. I'm going to go back to my feature file, go to this line of code. And I've just thrown in this breakpoint here. And now I'm just going to debug this code. So that test effectively used the Docker Compose where I defined multiple services, and I just had 2 in there, but you can have 50 if you need 50. Fired up those services, fired up my Spring Boot application, so I can actually now, because I'm firing up the test as a debug in my Spring Boot application, put breakpoints in my Spring Boot application along the way, so I can test my startup on my Spring Boot application. Those containers are up and running, and then I can put breakpoints in my test code and see how everything's working together. So this is just to demonstrate in my Spring Boot application a breakpoint. So I'm testing, this is my microservice that I'm developing, and I need to talk to that Kafka, and this is the breakpoint that basically lets me look at, did I get all the settings I'm expecting from Kafka? And yes, I did. So very useful in that regard. We'll let it run through. And then we'll hit this other breakpoint. And I usually just start dancing across the floor. Distract. And then we hit this other breakpoint. That was planned. So we hit this breakpoint, and there you can see the browser's being remote controlled. Or can you? It's not this browser. I promise it's not this browser. But where is it? Where is this browser? Well, actually, this is a containerized browser. And so what we'll do is we'll open up this magic tool, VNC. And this is genuinely that browser in a container being remote controlled, and I'm VNCing into that container. And so right now, we could take this line, and we could evaluate that line. I do know the keys for this, but when I'm standing up here, I can never remember them. So here's this line, and we'll just, I don't know, change this to, anyone got a website? Google.com. That's a complicated one. How do I spell that? Oh. So I evaluated that result. So I'm actually, talking to that browser in my code in a debug breakpoint. And if I go here, voila. So that's kind of the magic behind this whole end-to-end testing scenario. And then I'll just let that play, and we'll watch that container basically get shut down. So it closes the browser, shuts that down, and we're done with the test. Now, so who likes that? Hands up. I'm glad you like that, because that's like my big thing today is I've got all that test running in the background. What's the advantage of that? Well, one, I don't have any Chrome driver installed on my box. So if anyone's tried to set up Chrome driver on their box, or Edge driver, or Gecko driver, and get them all working together on your local machine, you know what fun that is. And yeah, that was in my my slide back there. That fun bit. No, that's not fun. That's real pain. So it's taken all that way. And the next one is, I can use that in my build pipeline. So that was just without any UI, that test running. And if we just go back and we'll run this now in our terminal, add a new one, and we'll just do a Maven verify. Does everyone know why we do Maven verify, not install? Or clean, sorry? So a common mistake is everyone does Maven clean install or Maven clean verify. You shouldn't do that. You should never use clean. And this is from, his name's gone, and I had it on my lips just a second ago. The inventor of Maven. Robert Shortler, there you go, Robert, from Holland. Basically, they've done a hell of a lot of work for incremental builds in Maven, and no one uses it. Every time you type clean, you're deleting all the metadata that's been collected for an incremental build. And so you should just do a verify. Just a little tip there. In fact, I don't want to skip the tests. So we'll run this. This is just a Maven build now, not in my IDE. That's another advantage of the Arquillian framework is it doesn't change your day-to-day working. So it works in your IDE seamlessly as it does in the command line. So it's a goal of the Maven, the Arquillian framework, is to test everything in the way that you would work normally. It doesn't change anything. You just add a few bells and whistles. It's not changing your day-to-day. And that leads me then to getting close. GitLab. I know there are a lot of build servers out there, and again, this is just a very opinionated opinion, which is my opinion. GitLab, hands up who's using GitLab. So a good deal of you. Who's using Jenkins? The rest. So I used to be a Jenkins user, and no one could have sold anything else to me ever. And the day that I got told by the company I'm working at now, we're going to be using GitLab, it was like, another wheel reinvented. Let's go and play with that wheel. And no, this is really, really good. I just, I can't sell it enough, and I don't get any money for that. It's not even in the book. We do Jenkins in the book, so don't buy the book if you want to do GitLab. So my opinion's kind of changed on that. I was introduced to this probably a year ago now, and there's just no looking back. It's an amazing, amazing build tool. So if you're struggling with Jenkins in your pipeline, or having a pipeline in Jenkins and you struggle with that, come along to GitLab and play with GitLab. And what I've actually got running here, I know you're just about to hold that sign up. I'll just do a Docker PS here. So funny enough, Docker, we all like playing with Docker, and this is in the background GitLab and GitLab Runner. So you can actually run this on your local box and test and debug against it, and that's why I like this version of it. You can download the image in Docker. I think I have it linked in there. And so that's how you would run the Docker version of GitLab, just a really simple command line. It's not that simple, but you just need to modify it for your local machine and fire that up. And then you have this amazing build tool, which supplies you with your local CI/CD environment. And so all the stuff I've been doing, you can see me playing for days and days and days and days, starting with a lot of failures and eventually getting all the way to my green build at the end with an optional. And we can just go in there and check out the build, the most recent build. And you can see that's basically just the Maven build with the whole tests getting fired up in the background. And we have a green build at the end, and that's tested against Chrome. So that Chrome image is actually being tested in my CI environment. And I've not done anything in my CI environment other than provide it with the Docker containers to run those tests and the Maven containers to run the Maven part. And that, ladies and gentlemen, is pretty much testing Java microservices, or at least helping you go a long way into testing your microservices. Thank you for your time. Any questions? Test containers is a similar product. I think, so the question was, how does test containers compare to Arquillian, and how does Arquillian compare to test containers? It would be a lie to say they're not competing. So they are competing, but this was the reason why Arquillian moved away from being a container test framework to an anything test framework. It's now just a test framework, and that's probably what I'm selling here. I am a committer on the project. I don't work full time on it. I've done like merge requests in the past, but I'm a user, or originally a user of Arquillian. Found it great, fixed some bugs, and I now do quite a bit of pull requests on the Arquillian framework. So I'm going to be biased and say I've tried both. I'm obviously very, very familiar with Arquillian, and I prefer to stick with it. It just does what it does. And if I need to change stuff, I actually go and download the code and change it and fix it and put a patch back in. And I'm on the Arquillian community side, way more involved than I would be on the containers, test containers side. But test containers does pretty much the same thing. It will orchestrate your Docker containers. So try both. It's that. Do you drive a Porsche or a Mercedes? I don't drive either of those, but it's like, which car do you drive? Go and test drive the one that you want to use and use it. They both have four-wheel, steering wheel, engine. It's a matter of choice at the end of the day. So that's Arquillian's kind of my top pick in that, but test containers is a perfectly legitimate alternative. Any more?
Any other questions?
Yeah.
What is your experience on pipeline CI/CD with multi-browser testing, multi-versions,
multi-browser testing in the pipeline? Well, I've just demonstrated the way that I loaded that up was in this Arquillian file. So So in my Arquillian file, I'm actually using the standalone Chrome debug image. So that was the image that was fired up with the Chrome driver and the Chrome browser. There is a Chrome image and a Firefox image that are provided by Selenium, so they're the official built images from Selenium and Firefox. So so you can definitely test against those two. For the Edge, I just had a virtual PC image basically for that to fire up that and run against Edge with the Edge driver. So in that sense, I'm just using image-based technologies or Docker-based technologies to fire up that environment that I test against. And the VNC that I use was just remoting into that. So I installed the VNC server. So the debug image has the VNC server running on it, so you can just go in and check it. Something I didn't demonstrate was putting a breakpoint in JavaScript, which is a time issue. But basically, you could go in to that image through VNC and put a breakpoint in your JavaScript and run your Spring Boot application that talks to a containerized Kafka and Zookeeper that hits a breakpoint in the JavaScript in the browser.
And a little more tricky, and mobile platforms.
Yes, I mean, any image that you can imagine you can fire up in a containerized environment, you can fire up. There is, try to think of the name now, which is like the grid, Selenium. Selenium, so not Selenium. Selenium is a grid, and it's a cloud provider that provides all those images. And you can say, I want to test against different versions of Chrome, different versions of Firefox, different versions of Internet Explorer, mobile devices, that kind of thing. But they're exactly the same principle. It's an image, it's a container, and I can load that container through Arquillian, get that fired up, connect to it, and do my end-to-end testing in that container. And it's just a case, I can run those in parallel. So this build runner is its own runner, and it will fire up, I can have 10 runners, and then have 10 parallel builds running against 10 different browser images. And nothing on my local machine, nothing, you know, it's all containerized.
Any other questions?
Can I get a selfie?
Sure.
Can someone do a selfie? Because I forgot my phone on my thing. Can someone phone me and like ping me back? Because it's kind of fun to be up here with you guys.
Let's turn around to the audience.
Yeah.
Cheers. Okay.
Awesome.
Thank you guys.
Thanks for coming, everybody. Enjoy the rest of the show.